An AI model can generate hundreds of lines of complex logic in milliseconds, but the moment it finishes, the process slams into a wall. It sits idle, waiting for a human to read, comprehend, and evaluate the result. This dead time is the primary bottleneck in enterprise AI. The machine is ready for the next step instantly, but the workflow is tethered to the reading speed of a human operator. Relying on a person to manually check every iteration and type a fresh prompt is a framework that cannot scale to match the throughput of machine compute. The alternative is an architecture where the AI critiques its own work, identifying failures and rewriting logic without waiting for user keystrokes. Breaking this bottleneck requires moving past the chat box and adopting the same systems that run a modern, automated production line. This is loop engineering. It isn't a new way to write prompts, but a system for building macro architectures that prompt the AI programmatically. Every functional loop relies on 4 components: a trigger to start the task, the execution where the agent acts, a verifier to check the work, and a state to maintain memory. This mirrors the logic of industrial manufacturing. Factories use control systems to constantly measure the quality of their output against strict performance indicators. This chart shows how industrial systems manage process variability. Wide fluctuations on the left settle into a flat, optimized line as the control loop applies adjustments. Software loops apply this principle to AI, using deterministic tools like test suites to measure code drift. Here, the loop categorizes every failure in a Pareto chart, so the system knows exactly which bugs to fix first. This prioritized data feeds back to the agent as new instructions. The machine iterates, correcting its own logic until software variance reaches 0. By viewing AI through the lens of industrial control, companies can move away from manual prompting and build a more predictable, scalable engine. While the theory is clean, engineering the precise logic that tells a loop when to stop is a significant technical hurdle. A poorly designed agent can fall into a doom loop. It hallucinates that it's making progress while actually burning through your API budget in an infinite cycle. Our 30-day Executive AI Accelerator is designed to help enterprises build these fail-safe, autonomous workflows correctly the first time. The difference between a runaway AI experiment and a profitable autonomous system is the quality of the underlying architecture. The most robust version of this architecture is the reflection pattern, designed for complex reasoning tasks. Reflection separates the maker from the checker. One specialized agent generates the work, and a completely separate agent evaluates it. The evaluator acts as a ruthless auditor, grading output against strict constraints and rejecting logic that doesn't meet success criteria. To ensure the loop actually improves, the system uses what's called episodic memory. Every time the evaluator rejects a draft, it logs the exact failure reason into a persistent state file. On the next cycle, the maker reads this log. It understands what went wrong previously, generating a refined version instead of repeating the mistake. This architecture changes the reality of development. The machine debugs and refines its own logic autonomously, while the developer focuses on higher-level goals. High-value engineering is no longer about micromanaging an AI's output line by line. The new frontier belongs to those who design the complex closed-circuit architectures that allow these agents to reason continuously. Subscribe to the channel for more blueprints on enterprise-grade AI systems. Building automated systems is a critical step for any organization aiming to achieve true operational scale.